Hi everyone, this is the next installment of the build video. I have the robot almost completed. Turn it on. Have GPS finally installed over here on this side. That is initializing. But the feature I'm going to show you today is the front headlight, which is now you can dial that in. I think I'm going to show it from this angle. You can see the colors a little better. Let's see. You get an idea for the colors. So with this we can set the radio. Radio is in position 0. I can turn the light off, turn the light on, holding the rudder for 1 second. I can put it in position 1. This actually is a position that stops the motors. Go up and down, it turns on the lights. I'm in programming mode, and on the right I can dial in red, green, and blue channels, dial in whatever values I want. Here I want to program a red. I can go red, proportional, there's a green, and a blue. By combining those colors, I can create various color combinations. There's with all red, all green, and all blue. A little red and blue, nice magenta, and all three make white. This next segment is going to highlight some of the telemetry features. Until I get a ground station properly programmed, I'm using Selmaware's StampPlot Pro software. The developer version lets me just plot values that are coming down off the serial port. In the top section here you can see that we have the current, voltage, and timestamp that's coming off the telemetry. And then this green values panel have the proportional, control, integral, derivative, the maximum values. Helps us to dial in the PID parameters when we're outside, especially. I had some that were working fine for indoors, but when I got outside they didn't work so well outside. So how this works is with the radio in position 0, we can, once we enable the motors, it sends those values over here, and you can see that I have 1.15, 1.5 for the proportional, integral, 0008 for a little derivative, 35 at the integral max, and kV happens to be a motor proportionality constant that maps the PWM of the motors with the quadrature encoder velocity values. Right now I have it pretty much dialed in so that 100% PWM on the motors shows up around 100 on the values for the velocity. So right now it's about 1 to 1. Under a really heavy load it should definitely change. The 100% PWM values for the motors is going to show up more like maybe 80 on the velocity, so that can get changed. So I can modify these values. What I do is, here I'm actually plotting the response of the system. So the motors are enabled, and you can see that I can look at the velocity values that are coming from the motors. So if I don't like what I'm seeing, and I can change these values, say I go here and I change this to a 2, for example, that should really make things a little bit awkward. And to load these values into the microcontroller, what I do is I put the gear channel to position 2, and I apply a throttle low, high, low, and we should hear 5 beeps as we get the 5 values read in. There we go. And then we can confirm that by going back up to position 0, re-enabling the motors, and you'll see that those values had not changed, so that they actually got written back to the computer, so we know that those values are indeed what I programmed in. This should not be very happy, actually. You'll see that it works better on the carpet, but you see it's a little oscillatory for what we're seeing here. But K proportional is a little bit too high. So I can fiddle with these values till the cows come home, and I'll show you what happens when we go a little bit too low, too damped. Go ahead and read these in. Yeah, that took. So you have to wait a while for the integral term to kick in. Playing with these, we can end up getting just the right values for getting the robot to drive quite nicely, with all 4 wheels having a PID control on the velocity. The final stage then will be to finish the GPS coding to get the driver written for that, so that I can get the latitude and longitude and the timestamp and ground speed of the robot, and then interface with the Arduino board for the back scrolling text display, so that I can display proper status messages. Then ground control station will get written, maybe exploring the Mavlink protocol, and that will be it. I actually have free RTOS implemented on here. I'm loving it. I have like maybe 6 or 7 tasks that are running, all with various priorities. So, working nicely.